Today we're going to talk about spectroscopy and the electromagnetic spectrum. Energy travels through space via electromagnetic radiation. The electromagnetic spectrum is a continuum of all the different types of electromagnetic radiation, or light, from radio waves to gamma rays. Electromagnetic radiation travels in waves, but also has particle-like properties and can travel in the form of photons. We'll explore this in more detail in the next video. Spectroscopy is the study of how matter interacts with electromagnetic radiation. This is a picture of the electromagnetic spectrum. You can see that radio waves have very low energy. The wavelengths are very long and the frequencies are low. Gamma rays, on the other hand, have very, very high energy. The wavelengths are very short and the frequencies are very high. And this will make more sense in topic 3.12. Electromagnetic radiation transfers energy, and this can affect matter. How a particular molecule is affected by this energy depends on both the identity of the molecule and the wavelength of the electromagnetic radiation it is subjected to. Different wavelengths of radiation can affect the movement of a molecule or the molecule's electrons. There are 4 different aspects of the behavior of a molecule that are affected by radiation. One of them is translation, and this is the molecule moving around as a whole. Another is rotation, or spinning around. When we talk about this, we're talking about the rotation of the molecule as a whole. Vibration means the oscillation back and forth along the bonds, and electronic transitions, which involve the actual moving of electrons from one energy level to another. Microwave spectroscopy is used to identify molecular rotations. Microwaves are low energy radiation. They're much lower on the spectrum than visible light. And when microwave radiation strikes a molecule, especially a polar molecule, it causes the molecule to rotate. This is how it works. All electromagnetic radiation, including microwaves, consists of oscillating electric and magnetic fields. Polar molecules will try to align their dipoles with the oscillating electric field, and they're going to keep changing their orientation as the field oscillates. There's some complicated physics going on here, but the end result is that the molecules hit by the microwaves start to spin. Microwave spectroscopy is one way that chemists can explore molecular rotation. Infrared spectroscopy explores transitions in molecular vibration levels. Infrared radiation is higher in energy than microwave radiation, but lower in energy than visible light. Infrared radiation is associated with vibration of the molecule, especially along its bonds, which will tend to wiggle and bounce around like springs do. Each type of bond tends to vibrate at a specific frequency. It takes more energy to vibrate molecules that have stronger bonds. Infrared spectroscopy takes advantage of this and can be used to identify the types of bonds present in a molecule. Ultraviolet and visible radiation spectroscopy explores transitions in electron energy levels. Visible light is higher in energy than microwave or infrared light, and the energy from ultraviolet radiation is higher than that of visible light. Visible and ultraviolet radiation can excite an electron from its ground state, that means its lowest energy level, to a higher energy level. Very specific amounts of energy are required to excite an electron from one energy level to another. Electrons in their excited states are not very stable, and eventually they return to the ground state, and when they do, they emit a photon of light that has the same energy as the energy that was required to excite the electron. Ultraviolet and visible radiation spectroscopy use an instrument called a spectrophotometer to investigate the frequencies of energy that are absorbed by a substance when it's exposed to visible or ultraviolet light. And this can be very helpful for determining concentrations of a solution. We will explore this type of spectroscopy more in upcoming videos. And in case you wondered, at higher energy levels, such as those of some ultraviolet rays, X-rays, and gamma rays, you can get complete ionization. In other words, the electrons completely fly off. We call these types of radiation ionizing radiation. Here's a summary of the types of radiation we just talked about, as well as their effect on molecules. Spectroscopy can be used to explore the effects of different types of electromagnetic radiation on matter. Microwave radiation is typically associated with transitions in molecular rotation levels. Infrared radiation is associated with transitions in molecular vibrational levels, and ultraviolet and visible radiation are associated with transitions in electronic energy levels.